To show you something I came across on the Hendey tool and gauge maker lathe. It has to do with the bearing block for the taper attachment, and I'll take you handheld. I want to show you what I'm seeing here, and we'll talk about how to fix it. So got the cross slide all set up here. This thing hanging out the back, that's the extension for the taper attachment that goes on the back of the lathe. So what it's got here, well, let me show you. Alright. You can see, boy, those ways look nice. Don't the ways look nice, the scraping? That's the lead screw right there, okay? And there's like a little hub, and then it's a straight portion, 3/8 diameter. And what that's supposed to do is it's supposed to be an axial thrust bearing on there. I think it's a needle thrust bearing. It's supposed to be a thrust bearing inside there. This is not pushed in all the way. See it? Not quite pushed in all the way. There's supposed to be one in there, and then a nut to tighten it all up, and the taper attachment would move this, you know, in and out. So what I want to show you is there's some preload on this shaft. Let me do this as steady as I can. When I pull this block out, the shaft is going to spring to the left. I want you to kind of see if I can do this without jostling. Ready? See how it moves to the left? Made that sound? And I can't get it back in unless I do that. So let me do it again. Watch the shaft, it's going to go to the left. Did you see that? Okay. Now you see that hole down in there? That's the binding hole that locks this whole thing up when it's not in taper mode. So the needle thrust bearing goes in there, and the needle thrust bearing goes in there. So that locates, you know, the feed screw fore and aft. This whole bearing block assembly gets locked out by that little pinch rod hole that comes through there. You can kind of see it, which is tightened. See on the way wiper, there's a slot for a bolt which pushes on it. So when the taper attachment's not in use, this gets locked out. You can kind of see that little stripe down the center, along the center. So what's going on? Why is this thing, you know, kicking off? Basically, it's preloaded to this side, right? I mean, there's some flex in it, but this rod, which is the cross feed screw, is too far this way. So what's going on? The nut is there, right? That's where the nut is fastened to the cross slide. But let's look over here. Let's come on. So I thought of a different what could be happening. So I took the screws out of this assembly here that holds the front end bearing and the dial. And I want you to see this. So I'll pull this out. Okay. Now see, there's pins in there. There's a pin there and a pin there. And there's a boss that goes in there, but it's not piloting on that. So there's a little bit of force pushing that in, but not much for alignment's sake. But let's just say I leave that out, right? I just leave it out. Actually crooked it a little bit. So now let's go around the back, and I did this before. It is easier putting it in. Very little side force now. Watch this. You can watch the end. I don't know if you can see it. See how that moves? right? So what's going on? I think the front's cocking the back and pivoting off the lead screw. So you gotta still pick it up. No. All right, now let's watch it come off. Ready? Watch that shaft. All right, it moves a little bit, but gosh, hardly not much at all. It's way better than it was. See? So, I don't know if loosening that would help. Maybe a little bit. I don't think there's much. That's aligned pretty well. I might loosen that with the big fat screwdriver. What I'm thinking of doing is pulling those pins, right? I'm going to pull these pins. There's actually a knockout hole. And just see how it goes. Now, right ahead of that's a gear. I can feel the gear. I don't think it's going to hurt anything. I really don't. So there's got to be some slop in these bolt holes. But I'm going to do that. Knock these pins out. And just see how it behaves. So I'm going to try that and then I'll bring you back. I'm going to stop and measure this. It's supposed to be 450 deep, and it is 450. Nice. Alright, so it's the depth. I gotta run my final. I was staying 10 thou shy of the edge. Let me just go to my number, which is 1.25 inches. 2.4. I was going to 2.4. Here's 2.5. 250. 1/250. Loosen my lock. Alright, I suppose you're wondering what all this aluminum thing is. I got a heck of a mess here. I've been machining for, well, measuring and machining. I don't shoot a lot of machining. I really should. I don't know if you guys like it though. You could leave a comment and tell me if you like it or not. I gotta bring the shop back over. As a temporary thing, I'm going to forego the taper attachment. Now I've got taper attachments on other lathes, and I just got to figure out what's going on. I need to, I mean, one would think, oh, Doozer, just straighten the feed screw. Well, possibly. Possibly. But I don't know. I don't know if it's the feed screw. It orbits a little, not a lot. I don't know if the other elements are in alignment. I don't know if the bronze nut's in alignment. So what this is going to hold a thrust bearing, and you can see I got some square window slotty slot slots. This is going to float in these squares. Well, they're slots, end milled slots. It's going to float, and I got this. I measured that hole for where the thrust bearing is going to be, and it's offset pretty much exactly 1/8 of an inch. Yeah. This sucker was offset 1/8 of an inch between the bolt pattern for attaching the taper attachment. I think it's off 60 thousandths maybe from the hole in the slider piece. But let me get this deburred and blown off, and let me show you how it fits on to the lathe. Alright guys, it's almost 9 o'clock on a Sunday. I'm just working on this thing nonstop. So what I showed you guys in the milling machine was that sort of temporarily I'm not going to put on the steady rest at this minute because I need to figure out what I'm going to do about that slider being off. But anyhow, this is what I did. So there's the lead screw, or the feed screw I should say. There's a collar that was on it. I made this piece of aluminum. This is 3/4 inch aluminum bar stock that I cored out, drilled down the center for 3/8. Now that 1/2 inch thick block of aluminum that I was showing you milling, counterbored into that is a bearing, a thrust bearing, a ball type thrust bearing, and it's some weird metric size, 11.5 millimeter bore, which in inch speak is 0.453. I think it's a 64th dimension, but anyways, I pocketed out for the bearing with a 7/8 end mill. I think the outside of the bearing was 813, so 875 is going to be good for that. So yeah, zoom. So let me go around the other side. I'll show you all the goings on. Alright, so here's another one of those bearings. It's a ball thrust bearing. It's fully enclosed, so I got a can crimped over it, and there's a oh, that's just a nut, a 5/16 nut, like it's kind of like a check nut or something with a spanner hole. That's all it is. Anyhow, so there's two bearings, one in there with a 7/8 counterbore. I counterbored the 7/8 feature 300 thousandths deep. The bearings are 281 thick, so just below flush. So it leaves 200 thousandths wall thickness below this bearing. And I might put an elastic stop nut or something in here, something different. But anyhow, kind of see what I ended up doing is coming up with a center dimension. I got some nice thick washers. And I got some, it looks like a square hole. I slotted it in two directions, but I ended up in the neutral position. It's pretty much centered in the slot, in the hole, whatever you want to call that, the square hole. So so this is free to move around, and I indicated it in for center, and everything clears. The dovetail part clears and the flat part clears. Everything's kind of just finger tight right now. But let me go and crank. I still got to get my hand wheel. Let me crank this down. See, we're right at the edge here. Right at the edge. The crank's very smooth. Till it stops. There, it stopped. Now if you look, eyeball up at the chuck, the platform for the compound is beyond center, so that's good. We can face without an issue. And I got clearance. Everything fits. There's the gib on the left. So this is going to take the place of my taper attachment sort of semi-temporarily until I can figure out, what I want to do with this guy. So this hole is not perfectly centered. Well, it's perfectly centered, but the screw is not centered, and the screw has a little bit of orbiting. It's interesting, they did a back counter bore in there. Isn't that something? I don't know. I was thinking about drilling that open more. Before I start modifying this, I want to just think about it on what's the best avenue. If you guys could give me an idea. Basically, this hole has to go to the one side by about 60 thousandths, I think. $40 to $60. And it can float. I don't know why they got it so tight. They're thrust bearings anyways. If I drilled that up to 7/16 or something and drilled out them holes. The thing is, see how it's breaking out the top there? Those thrust bearings got a certain diameter to them. Like I said, I believe these are 13/16 and that's a 7/8 counter bore, and they can't really, well, it's got to go sideways. It doesn't have to go up. That's the up. Where it's breaking out, that's the upper. Or is it the lower? It's the lower, because there's the oil port on the upper. So I got to figure out what I'm going to do with this. Or the problem could be that the feed screw is off to the side, and this is correct. And I thought about slotting the counter bore for this screw and slotting where the shank goes through for the screw and moving this over. This side, I don't know how much sideways and dorking around moving I can do with this, because there's a gear right under here. So I don't know. I don't know how straight, I just got to measure everything and make sure everything's straight, everything where it needs to be on the front. So, kind of see, it all turns pretty well. And it doesn't orbit or nothing, it's all held. And this thing feels rock solid. I mean, it just feels good. It just feels good. It doesn't feel spongy. The Pratt & Whitney feels a little spongy. And I don't know, I got to dig into that, but this feels, I mean, there is no, I mean, there's not, I don't think there's 5,000s of backlash. I think this thing's super tight. So that thing's really good. All right. Just the chips that I've been cutting with this thing in the last few hours. I use the heck out of this mill. I love this 8520. Just, and then I've been over on the Sagami lathe. I've already cleaned 2 handfuls of chips out of here. But I've been turning shafts and doing all my making bushings and such. But I'm closing it down for the night. Starting to turn the lights off. It's raining. There's a piece of the piece I parted off. But I mean, I'm losing everything with these things. Yeah, this thing's got a whole nother shooting match, different situation style, but at least I got a taper attachment usable. I got a taper attachment for this too, but I think it's from a different machine because it doesn't have the right lead screw or feed screw. Anyhow, just gonna go in the house and clean up, put everything away. Yeah, there's a key in the chuck, but it hasn't had a cord on it for 15 years, so people are crazy. So that's my solution for now. I like it, it feels good. I'll just keep the taper attachment in the box, and I don't know. But anyhow, yeah, I'm tired. I've been in the shop probably 8 hours or more today. There's that new lamp I got up on the wall. The one that looks like a factory roof. It's kind of cool. I just screwed it to the wall. That kind of lights up my area here where my mill cutters are and all my drill bits and taps and everything. So let me shut this off. Closing down, closing time. But thanks for coming along with me. on the journey to getting this thing back running. Hope maybe this helped some of you guys. Till next time, this is Doozer Shop.